Metamouse is a pilot system developed at the University of Calgary to investigate end-user programming by example. The idea is that the user demonstrates a task for the system which infers appropriate constraints and actions and programming constructs like variables, loops, and branches. The system learns graphical editing tasks, for example, constructing objects with parameters, or repetitive editing such as aligning boxes, maintaining constraints once object parts have been moved, and so on. In the first task, we'll create some envelopes. This is just a simple task to illustrate the use of construction. We activate the learning system by telling Basil it's time for a lesson. The turtle icon appears at the left of the window. The first step is to select a box. Next, we move Basil to the top left corner and draw a line down to the middle of the box. We then construct the rest of the flap and the other folds in the envelope. Having done so, we tell Basil this lesson is over. A dialog box appears asking us to give a name for this task so that we can recall it later on. Now let's suppose we want to create another envelope. We simply call up the task from Basil's Tasks menu. We have to select a box for Basil, but having done that, Basil is able to construct all the lines of the envelope. Now suppose this time we want to create an envelope but a slightly different style. Again, we call up this task and select a box. Basil draws the flap of the envelope, and we like the way this looks. But when he predicts the first part of the fold, we decide that's not what we want, so we reject his prediction. This will create a branch in the program. We then demonstrate the type of fold we actually wanted, and then record the lesson. Now Basil knows how to create two types of envelopes. Here's an example of a repetitive editing task. We want to sort a group of boxes by height and space them evenly apart. To help me space the boxes evenly, I construct a short line, and this will give Basil an explicit constraint to use. Because the line starts and ends in empty space, there are no touch constraints. Basil asks me what determines its endpoints. I reply that I, the user, should always set them. I then draw another line called a sweep line, which I'll use to compare the heights of the boxes. In this case, I want Basil to draw the line always at the same location near the bottom of the screen. I then grasp the sweep line and drag it up until it contacts the top of the shortest box. The small dark squares mark special points on objects called handles that Basil can sense. Basil indicates those touch relations he considers important by enlarging the handles. Now it so happens in this case that the shortest box is just half the size of one of the other boxes. I toggle all the handles on the taller box. The next step is to grasp the box that I've just selected with the sweep line and move it down to the end of that spacer line. Now you'll notice that it's also touching one of the other boxes, but Basil notes that the important constraint is the contact with the end of the spacer line. I then advance the spacer past the first box and reselect the sweep line. Basil's seen this action before, and so conjectures a loop. Basil predicts that the sweep line should be moved upwards until it reaches the top of some box. Since I agree with Basil's prediction, I click OK in the window at the bottom of the screen. Basil then moves to grasp the box, moves it down to the spacer, and advances the spacer. I agree with all these predictions, and Basil continues through the rest of the task. At this point, Basil is doing virtually all the work. I'm just clicking OK at each step. When Basil finally runs out of boxes, he asks me to show him what to do next. I delete the sweep line. This forms a branch at the end of the loop. an action to be performed when the loop can no longer continue. I then delete the spacer line and tell him the lesson is over. In the third task, we're going to edit an organizational chart, aligning 3 boxes to an input guideline. That's a custom operation not supported by the drawing program, and reconnecting them in a slightly different way to the box at the left. The first step is to create the guideline. Since its endpoints seem unconstrained, Basil questions me. Next, I show Basil how to construct the sweep line. I'm going to use this to ensure that I keep the box at the same vertical level when I drag it across to the guideline. This isn't strictly necessary, since Basil would interpret a nearly horizontal path as strictly horizontal when he performs. I always want the sweep line to be drawn near the bottom of the screen, so I tell Basil. I grasp the sweep line and drag it out to contact the first box. I move the box over to the guideline, and then select and move the tie line, and I'm going to put it at the middle of the box rather than the bottom. When I re-grasp the sweep line, Basil matches this action with one he's already seen and predicts the next step. He skips past that box on the left because the constraints for selecting the next box include contact with a tie line from the lower left corner. The second box has to be moved leftwards to the guideline, so Basil generalizes the path from rightwards to along the x-axis. Basil has now successfully predicted the second iteration of the loop and proceeds with the third. I'm relegated to clicking on the mouse button to signal my approval. Well, it may appear that Basil is smart enough to do just about anything, but that's far from true. Let's look at a slight variant of the previous task to show some of the mistakes that Basil is able to make. We create guideline and sweep line as we did in the previous version. I then move the sweep line up to the first box and move it to the guideline. Next, I draw a tie line from that box to the box at the left. When I reselect the sweep line, Basil predicts that we move it up to the next box. But Basil hasn't particularly distinguished the box at the left, so he selects that one. In fact, I want him to move to one of the other boxes, one that doesn't have a tie line coming into it. So I reject the prediction and move the sweep line up to the next box. Basil then predicts that we should move the box over to the guideline. He tries to predict that we draw a line from that box, but he doesn't seem to know where to draw it to. Basil believes that he should be drawing the line to some box he hasn't seen before. Since he can't find another box off to the left-hand side, he gives up. So I show him that he has to draw the line to that same box. I then reselect the sweep line, and Basil predicts what we have to do with the third box. Luckily enough, he's learned where to draw that tie line. If Basil had reasoned a bit about the goal or the constraints on drawing a line, he would have made that prediction as I expected him to. You've just seen several examples of an apprenticeship learning system at work. To date, these systems are quite rare, but in the past few years, research in programming by example has really opened up. Much further work remains to be done, and several researchers at the University of Calgary are deeply involved with this at the moment. If you would like more information, feel free to contact us at this address.